Okay, I think it's time to sit down. So is this mic actually on? I can't tell from here. Can you hear me on the mic? Yeah? Okay, so then you'll have a copy of it later on. I'm Peter. It says here I'm Max's good friend. You saw me at the beginning of the term, if you remember that far back. Max decided that the current flu virus was likely to go extinct, and he wanted to save it for posterity, so he went out and got it for himself. And he got rather more of it than he bargained for. As of yesterday, he's well on the road to recovery. He's quite sure he'll be seeing you with exams on Tuesday to return them, so he's okay. But if you'd asked him over the weekend, he probably wouldn't have taken that point of view. You're pretty sick with it. So it says I'm Max's good friend. I think that's a good enough description. Now, this says last time, and Max gave me notes, you have to understand. So it's not only I have that. Max gave me handwritten notes here, and it says here, they know all of this. That's what I was asking you about. All right, someone know how I do it. It's on here somewhere. One of the TAs in the back? You want to come up and play with the volume? Sam, just come up and see if you can find it. It's here somewhere. Maybe it's on this thing. Wait a minute. That's screen volume, speech volume. Speech volume? Is that better? Well, let's see. If I did that, then you'd be blasted. All right, let me move this up higher. Is that better? I think it's as high as it goes. I'm missing something here. You're welcome to fuss with it. Yeah, that's as high as it goes, guys.
Everybody quiet.
Thank you. I bet you're right, but does that do it or not? Max gets louder than that? No, it has an on-off switch. That's it. It's better than it was. All right. Here, let me button the top. That should do it a little better. Well, that's what I can arrange. If you're in the back and you can't hear, you better come down. Otherwise, let's go on here. So Max says that you know all this. And just for the fun of it, let's have a show of hands. How many people actually could right now tell me, as you sit here today, what is the definition of MRTS? You got one. You got 1 out of 100. Is it 2? Do I have a second? But you know all this, don't you? No. Okay. No one ever does. So just so you don't feel bad, marginal rate of technical substitution. Before I walked into class, I picked up Jeff Perloff's textbook, and I opened to the right page. So you don't have to feel bad. I've been doing this for 40 years. Now, what I should be doing here is drawing where you can see it, a standard isoquant diagram. And I'm going to have to hope you're all right with that. And I believe Max draws them with 2 inputs, and he calls them capital and labor. And we all use K. Max wasn't doing it just for you. But he actually writes out capital with a K. That's because he's German and makes it happen. The rest of us would write it with a C. And then draw a curve. And what is this curve? This curve is all the combinations of K and L that make the same output. And that's an isoquant. That you got. Then next question is, suppose for some reason I were producing at this point, so much K, so much L. This much L, that much K, yes? And I wanted to describe a point nearby. I'm going to pick a point lower on the isoquant. Here's a point nearby. So I could make this trade-off. In this trade-off, I give up K and I get L, yeah? So I use less capital, and somehow get people to work a little harder, a little more, and make the same output. That's what that trade-off is. From the top point, you can draw this yourself, and call it A, to point B. Marginal rate of technical substitution is defined as the amount of K you give up divided by the amount of L you get. And we typically state it with a positive sign. But still, just amount of K given up per unit of L received, or amount of K given up divided by the amount of L received, output L constant. Yeah? And that's your definition. And so somewhere you have a pile of definitions, do you not? Textbook, your notes, whatever. Other than your notes from last time. You have it on the slides somewhere. I'm sure it's on the slides. If I were you, I'd go through, and every time he has a definition, I'd underline the definition, and I'd write down the definition somewhere. And I'd spend 10 minutes going through the definitions, because you can answer almost all of the test questions if you know the definitions. And if you don't, well, you're stumped. It's just an unfortunate fact. You got to memorize these things. Second thing that he must have defined last time is marginal product. Somebody give me a definition of marginal product. Yeah. Or capital, yeah, right. So amount of additional output from one additional unit of input. And then the last thing Max did is he related them. And I went to do that, and unfortunately that takes a little bit of work. I don't know if I can get it on a slide for you very well. So let me see what I can do here. The amount of additional output, actually a T, you get, yeah, is going to be, and we'll do it for labor, okay? It's the marginal product of labor times the amount of additional labor. I want to turn this around. I want to ask, how do I get one more unit of output? How much additional labor should I add to get exactly 1 unit more of output? It's everything you need here. The change in output is this number, marginal product of labor, times the amount of additional labor. I want to scale that so I get exactly 1 more unit of output. So how much labor should I add? How much? Can you solve this equation? I want this number to be 1, yeah? If I want this to be 1, and this is a number, what's that got to be? 1 over the number, right? 1 over marginal product. So if I added 1 over marginal product, and here I just need more space than I can do with a pen. 1 over MT labor is going to give you 1 more unit out. Suppose I took away 1 over marginal product of capital. How much output would I lose? Same exact question. Yeah, you were whispering it down there. Go ahead. 1, right? So that'll give me minus 1. So if I did this and that, would output change? No. Okay, so what's our definition of marginal rate of technical substitution? It's the amount I can change capital divided by the amount I change labor with output going nowhere. Okay, so how much did I change capital? 1 over MPK. How much did I change labor? 1 over MPL. And what does that give you? Right. So this and this and this are equal, and that's the last thing we're trying to show you. we're there. Fortunately, for me, most of what we do this time doesn't depend on that. Otherwise, I'd be in trouble. Technical progress. Is there technical progress? Does the way you make things change over time? Yeah? What about this? How many of you have one of these sorts of things? Yeah, all right. When I was sitting where you're sitting, I hadn't quite opened this building yet, so I was sitting in a ratty lecture hall like this in, say, 1971. Did I have one of these? How about the university computer? How powerful was it compared to one of these? Maybe the same, maybe less? I think probably less. Somebody go figure that out. You had a CDC 6400. It took up the better part of a room. It required 3 or 4 people to feed it and tend it. And I don't think it did more computing than what I have on my belt. It's certainly not more than most of the laptops you're carrying around. Not even close. That's an example of technical progress. Okay? You're getting the same thing done, computing, only it takes a whole lot less capital in this case to do it. And in the story I told you, less labor too. So technical progress is draw yourself an isoquant, say, aha, in 1971, this was the isoquant for computing. And where would that same isoquant be today? In or out? Out, up here, took more capital and more labor to do the same amount of computing as it did in 1971. Your level was 71. Or is that backwards? That's backwards, right? This is 1965. The output is 65. So today, it's way in here. So technical progress means that the isoquants shift inwards. And we distinguish 2 different types. Neutral technical change. And there we mean the thing doesn't change its shape. So the trade-off between labor and capital doesn't change. And with the strange title of biased technical change, where it does change. Mostly in the world, what have you seen? Have you seen new technologies just require less capital and less labor in roughly equal proportions, or something else? What have you seen? Or more capital, less labor. Right? So if you look at the ratio, you'd say, aha, there's an awful lot more capital now that is being used per unit of labor to get the same output. And you have to be careful there. What we really want to say is we want to say if factor prices were the same, labor costs the same, and capital costs the same. And then what happened when there was technical progress is we ended up with the same output being produced, but we used a lot less labor and only a little less capital. We're going to use less, by the time we get done, we're going to use less of both. Think about that computer. What did that computer cost? Oh my God, it cost ridiculous compared to today. What do they cost today? Almost nothing. But look at the amount of labor change. Now, one of you can do what 100 of us would have done once you have these computers. To save huge amounts of labor and relatively small amounts of capital. Why does it make any difference to you? Why do you care? Do people sometimes want to be Luddites? Go ahead, there's an answer. Go ahead. It's loud. It's what? It affects jobs. Yeah. So what's the first order effect if you invent a great new machine that does something? Perhaps what it does, I just walked by Yali's Coffee. There's a line of like 8 people there. You invent the automated coffee machine that you can speak from 6 or 7 spaces back saying, that'll be a mocha. And within a minute or two, mocha happens and blink, it comes off of your account on your phone or whatever. What's going to happen to labor then? Well, that's going to fall through the floor, yeah? And so then you have to ask, how are these people going to get reemployed? Otherwise, you have a pretty bad nest. So one of the things technical progress is going to do is very naturally, because it tends to be the technical progress tends to have the form of we have some new thing, a new machine that does something great. It tends to unemploy labor, and then you have an interesting political problem. And get the labor reemployed, or does the market do it for you? So to some degree, the market does it for you. To some degree, it doesn't. If you think the market works perfectly, just walk off campus in any direction and ask any of the people you see sitting on the ground. So it's not perfect. On the other hand, when you get out of here, you'll probably be employed. So it's not terrible either. You live somewhere in between in that nasty gray zone. So that's biased technical change, non-neutral, and they alter the proportion which the inputs are used. The proportion goes typically more towards capital. That's what happens. So now we have an idea of technical progress, and we make some small connection to the world of unemployment. And I think we leave it at that. Now we come to the main meat of today, which is costs. And we're going to characterize them in all kinds of different ways and draw pretty pictures. That's what we're going to accomplish. Then next time, if I understand how this works, you're going to take your isoquant diagram and you take what comes at the end of today, factor prices, and you're going to put them together, and you're actually going to be able to produce on a diagram this object that I'm going to talk about all day. The object I'm going to talk about is the cost function. Let's see. What I'm going to get to is how much money does it cost to produce output Q? That's the cost function. Output is, the function maps quantity of output to dollars. That's what it does. And there's some things you can tell me about it without even thinking. If output goes up, what will happen to cost? The amount of dollars it takes to make 4 things is going to be bigger or smaller than 3 things. Anyone in the back capable of the same? Why am I saying that? Bigger or smaller? I got an answer from the front. Is there an answer from the back? Quantity of output goes up. Does it cost you more to make more stuff or less? More. Okay, thank you. So C of Q is an increasing function. We already know something. So where we're going in 2 lectures is how do we choose what to produce given a certain production technology. So do we have production technology in our mind? I draw a set of isoquants. Yeah? That's a production technology. It tells me all the efficient ways to make output Q. And if I draw a lot of isoquants, it tells me all the efficient ways to make all outputs. That's our technology. Just a list of how do I make outputs. And so how do we choose what to produce given we already have this set of isoquants? First question is, do we do efficient or inefficient? Did Max define efficient for you? Do I need a fast yes, no? All right, let's draw an isoquant, and let's draw the X off the isoquant. I'm going to represent that X and everything on the isoquant all produce the same output. Yep? So X is off the isoquant but produces the same output. Does X use more capital than anything on the isoquant? Does it use more labor? So would you ever want to choose that as your way to make this output? Okay, that's inefficient. Use at least more of one input and not less of the other. If you remember your lecture a long, long time ago, we had more is better, right? Here we have more is worse. If I take a point on the isoquant, everything that has more capital or more labor and produces the same output is worse because it's inefficient. It uses up capital or labor needlessly. So we're only going to pick efficient production processes. That means we're only going to pick ones that lie on the isoquant. The isoquant is defined, actually, as the set of efficient ways to make the output. So if you had a big graph, there are all kinds of ways to make it. All the ones that you can draw a little box and they're in the wrong sector, the higher sector, they take those out. What's left will be yours. So you have the efficient ways. By the end of Tuesday, you will be able to draw this diagram and draw an isocost line on it, or a bunch of them, and show what is the least cost way to make this output. So you find out which K and which L produce the output at least cost. Max asked the question, why is this useful? I'm just going to put down this note to make sure I don't miss anything that makes it important. Okay, so why is it useful? Why do you want the least cost way of making your output? No, maximize your profits, right? Your revenues are constant, and your costs go down. What happens to your profits? They go up, right? Profits are definitionally revenue minus cost. Do you like profits? Well, presumably yes. Can I tell you a story in which, I use this story in my version of Econ 301, in which that was debated. So I'll tell it quickly. Once upon a time in, I believe it was Indonesia, there were many ways of pounding rice, of shelling rice. So rice is got a hull on it. Under the hull is the bran, the brown stuff, and under the brown stuff is the white stuff. And everyone takes off the outer hull. No one eats with the outer hull. And then most people actually scrub the bran off and eat white rice. Why do you do this? I mean, the bran's good for you and stuff like that. Can anyone give me a fast reason why worldwide you see people eating white rice, even though the bran is good for you? Let's suppose they don't care about rice. Personally, I don't like it, but let's suppose that's not the issue. What else happens? Anyone ever cook rice? How long does it take to cook brown rice? How much longer? 2x roughly? Suppose you had to go collect the fuel wood to do that. And the nearest place to get fuel wood was about 2.5 miles from home. Would you take the whole off your rice and make a white rice? Yeah, you would. Okay, that's why you do it. I think there's a second reason. I think if you take white rice, it's much easier to dry it. So you still will have the rice without it molding later in the time. So I think there's some good reasons why people do it. But that's not our story. Is there's many ways of cleaning the rice up and turning it into white rice. One of the ways is that you take a rock and another rock and you pound the rice. And you can tell me instantly what are the problems with that. What's the problem with that? What? Well, yeah, that may not be the problem in this story, but it's labor intensive. It's all labor. What happens to the rice? You get some of it broken, and what else is going to happen with the rice? Why don't you want hand-pounded rice in your house? It employs incredibly poor women in Indonesia. It would be a great way to make their lives better. Why don't you still want it? Even if you don't care about the rice being broken. You have 2 rocks, pound them. What's going to happen? I get a piece of rock in there. Yeah, all right. So the reality is they probably don't want this stuff, but the reality also was that the poorest people in Indonesia were women, particularly widows, and their livelihood was pounding rice. Yep. And along came a number of other technologies to do the thing. There were small rice mills and large rice mills and bulk facilities, and each of these other things had some amount of capital. If I understood right, a small rice mill was like yay by yay, and we replaced hundreds of women and produced a better product. And the paper by Peter Timmer says roughly, look, economics works. There's this wonderful machine that has a higher capital labor ratio, but when you work out the price of capital and the price of labor in Indonesia, the cost minimizing way of producing rice is this great machine. Can you imagine what the comment was? What would be your natural comment? Rah, 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 this all works. You got this great new machine. Produces a lot more rice. It's cheaper than it used to be before to produce it. And so this is great. So what's your comment? You know how it was produced before. How was it produced before? Yeah, were they poor? Did they have a lot of other things they could do? Did the labor market work really well so they'd immediately be reemployed as seamstresses or something? Okay, so what's your comment? You guys, you only get one out of every 3. They have to talk back there. What's your comment? What major do you guys have, ladies and gentlemen? What's your major? Political economy. Okay, now what's your comment? I just told you a lot of poor people got unemployed, they're not going to get reemployed, and then here I am, an economist, talking about being so happy about this efficiency. Is there no comment? Is it like, yeah, the efficiency is really good? Or how many of you think the efficiency was very good? It was a good argument for your case. You can try it again. So why is it not so obviously good? Yeah. Yeah, it doesn't take